Welcome back. This is the second lesson recording for IM2, January 11th, 2021. Okay, so now we are working on card number 8 to 11 of the decimals. Now we're going to use that pattern to factor the perfect square trinomial. Now first we need to look, is this three term? Yes, we do have three terms. Is the first term, the coefficient, is that a perfect square? Yeah, 9 is a perfect square. 4 is a perfect square. And they're both positive. Okay, so then we need to check if the middle term is fits. Okay, so what is square root of 9? Square root of 9 is 3. Okay, what is square root of 4? It's 2. Okay, so we want the middle term to be 3 times 2, and then we need to double that. So 3 times 2 is 6 times 2 is 12. And we do have positive 12, so that checks out. So this is a perfect square. That means we have the two parentheses, and the first number that's going to be square root of 9x squared is 3x, and then 3x. And the second number is going to be 2 and 2. And to get positive 12, they both have to be plus, right? So this is 3x plus 2 all squared. And you can quickly use FOIL to check if your factoring is correct. And that's always a good idea. Okay, next card, we have a trinomial. First term, remember if there is no number in front, the default number is 1. So I can always put 1, which is a perfect square. And 49 is a positive 49. So therefore, they're both perfect squares. So square root of 1 is 1. And square root of 49 is 7. So that means for the middle term, we are looking for 1 times 7. That's 1 times 7. And we need to double that, so we need to multiply by 2. 2 times 7 is 14. So we need the middle term to be 14, and we do have 14, but it happens to be negative. That means that we have x here and x here, and square root, and we're dealing with 7, aren't we? But it needs to be negative 7 and negative 7. So this is x minus 7 all squared. Okay, so the card number 10. Maya factored x squared plus 10x minus 25 as x plus 5x plus 5. Do you agree or disagree, and why? The first thing is this a perfect square? Yes, we do have three terms, and we have the first term, the coefficient of the x squared is 1. The constant is negative 25. We need this to be positive, not negative, because no two numbers are going to multiply to itself to get a negative number. So this does not work, okay? And if I use FOIL to multiply this out, I get x times x, which is x squared. That's first, x squared. And then outside is 5x. Inside is 5x times 5x is another 5x. And then finally 5 times 5 is plus 25. And I get x squared plus 10x plus 25. And this is not the same. We have negative 25 here, and that's a problem. Okay, so therefore this is not a perfect square trinomial. So now I hope you feel pretty comfortable with perfect square trinomial and figuring out the pattern that you need to do that. And that is always helpful because that way you do not have to factor, which takes a little longer than if you already know the pattern. Now we're going to be considering a new pattern. It's called difference of square. There is a special quadratic factoring number 2, difference of square. And to do that, you are going to be exploring card number 11 to 16 of decimals. So please pause the video and see if you can go through them now. And I will go through the answers in a minute. Okay, so now we're looking at card number 11, 16x squared minus 9. what do you notice about quadratic expression? Okay, so 16x squared, maybe you might have noticed that 16 is a perfect square, 9 is a perfect square. But we also have a negative sign here. Okay, so remember with the previous perfect square trinomial, you could not have a negative um, as the constant. But this time we have a negative constant. But it is a perfect square. Another thing you should notice is that we only have two terms. We are missing the x term, aren't we? Okay, we have x squared term, we have a constant, but we are missing the middle term, the x term. Okay, so then move on to card number 12. Read this and see if you can process it clearly. Okay, the quadratic follows a pattern called difference of squares. To match the pattern, the quadratic only has two terms. The previous complete perfect square trinomial had three terms always, but this one only has two terms, the x squared term and the constant term. We're missing the x term. And the two terms are subtracted, as in the constant is being subtracted. Okay, so it's minus 9. Thus, the word difference. The difference comes from the word subtraction. Both numbers are perfect square numbers. So 16 is a perfect square and 9 is a perfect square. Thus, the word square in the name. So it's a perfect square. No, it's not perfect square. It's a difference of squares. So now that we know what pattern we're looking for, select the quadratic expression that follow the difference of square pattern. Remember, it has to be two terms, and the second term has to be subtracted, and both the first term and the constant, they have to be perfect square as well. Okay, so which one? X squared, that's 1 squared minus 49. They are both perfect square. 1 and 49 are both perfect square. We only have two terms, and the second term is being subtracted. So I am going to click that. What about this 9x squared? Is 9x squared perfect square? Yeah, it's a 3x all squared. And then 100 is a perfect square and we're being subtracted? Yes. What about this? We have three terms, so that is not going to be a difference of square. We have two terms here. Okay, 25 is a perfect square, 4 is a perfect square. However, we're adding here, so that's no good. We need this to be subtract. Okay, and then finally 36 is a perfect square, 1 is a perfect square, and we have two terms being subtracted, so this would work. The next card is just self-checking the answers that you should have. And all right, so let's read this. In order to factor the difference of squares quadratics, we can introduce the x term with a trick at 0x. Okay, so when you have 16x squared minus 9, we're saying that there is no x term. Or we can say it's a 0x. 0 times x is just going to be 0. So we can add 0x to it because we would just be adding a 0. So we can always add a 0 to an expression without changing its value. So we are allowed to do that. So now go ahead and factor 16x squared plus 0x minus 9 using either the area model or the grouping method. To do that, we start with the diamond 16 times 9. That's going to be 144. But it's 16 times negative 9, so that's negative 144. So, and we have 0 at the bottom because we have 0x. So we are looking for two numbers that multiply to negative 144, but that add to 0. Okay, so that means we're looking for factors of negative 144. That means one's going to be positive or one's going to be negative or positive. So it's going to be plus or minus plus. Now, if I can start with 1 and 144, and we're looking for the difference to be 0, but we know that that's going to be a huge number. So we're basic for it to be 0. It needs to be two identical numbers. So we take a square root of 144, and that's 12 and 12, right? And so one's going to be positive, one's going to be negative. So then we can split the 16x squared plus 12x, and then plus minus 12x minus 9, and put my parenthesis. First two terms and then last two terms. And you have 16x and 12x. The common factor is 4 that I can take out. That leaves me with 4x plus 3 here, plus, and then, oops, that should be 16x squared, wasn't it? Okay. All right. And next term, negative 12 and negative 9. So I know that I can take out negative 3. Negative 3 times what is negative 12x? That's 4x. And negative 3 times what is negative 3? That's plus 3. Okay, notice that I have 4x plus 3, 4x plus 3, both factors here. So take that out, 4x plus 3. But I am left with 4 minus 3. So notice that when I factor this, I do get 4x plus 3 and 4x minus 3. Okay? And again, you can use FOIL to check if your factoring is correct. Okay, now notice the relation between the factors and the original quadratic. So we have 16x squared minus 9 became a factor to 4x minus 3, 4x plus 3. Notice that 4x and 4x is the same, 3 and 3 is the same. What is the difference? We have 1 minus, 1 plus. Okay, and that's always going to be the case. So if I take a square root of 16x squared, or just 16, square root of 16 is just 4. And that's where the 4 occurs. Okay, and then square root of 9 is 3, and that's where the 3 comes from. Okay, however, because we only have, this is a difference of square, one's going to be positive, one's going to be negative. One of the factors is going to be positive, one's going to be negative. Okay, so to solve 25x squared minus 4, we need to be thinking about what is the square root of 25. That's going to be 5. Or square root of 25x squared is going to be 5x. So I'm going to put 5x and 5x here. And what is the square root of 4? That's going to be 2. And one's going to be positive, one's going to be negative. As simple as that. We don't have to go through the diamond. We don't have to go through either the grouping method or the area model. You can just go straight from here to there. Okay, again, it's very good idea to always check to make sure that the answer is correct, especially in the beginning, because this is somewhat unfamiliar to you. Okay, use the FOIL. First with FOIL, that's going to be 5x times 5x. That's going to be 5x squared. Outside, 5x times negative 2 is going to be negative 10x. The inside is going to be positive 2 times 5x. That's going to be positive 10x. And then finally, last with last, positive 2 times negative 2 is going to be negative 4. And notice that when you do this, the 2 middle term is always going to cancel out to 0. And it goes away. And you're just left with 5x squared minus 4, which is, oh, I'm sorry, I'm sorry, that should be 25, wasn't I? Okay, which is what we started off with, 25x squared minus 4. Okay, so that's why you have the same numbers, but with one positive and one minus negative, and they cancel out to 0, and that is the reason you are left with 2 terms. Okay, I am going to recap what we've discovered from the Desmos exercise in the next lesson recording.